Okay, let's see. Jolene, first one. What do you think is the first one? Wonderful. Two powers together, we multiply them. So it's 5 to the 42. Ibrahima, next one. Say it louder. Great. When you have one power, you distribute that to everything you have inside your parentheses. Zachariah, the next one. Perfect. The same rule in division or multiplication. You just distribute the power to everything. Aditya. 3 to the what? 81. Perfect. So when you have same base you're multiplying, you just add the powers. Skylar, next one. If you do 5 minus 19, then you get a negative power, but you cannot leave negative power. So what's the final answer? Good job, Freshly. See, I said every time, wherever you have the bigger power, keep that on its position. So we have 4 to the 19 bigger. We want to keep our 4 to the 19 on the denominator and then subtract the numerator. So it's 1 over 4 to the 14. Diana. 9 to the 11. This time our 17 is bigger. So we keep our 17 on the position of 9 to the 17 and subtract the 6 power from the denominator. So 9 to the 11. Evelyn, right? Next one. You're converting negative power into positive. X. Our goal is to have x to the 1, from x to the negative 1. So what can you do? It becomes a fraction. So we can convert negative power into positive if you make it as a fraction or if you switch its position. X to the negative 1 currently is on the numerator. So if you put it on the denominator, it becomes positive. Emma, next one. Good job. Same rule. We have negative 2 power. We want a positive 2. No problem. Just put it on the denominator. Maria, next one. Maria, right? Sorry. Sorry. Sophia. Sorry. 1 over x to the positive n. Jean, next one. We want our negative n to be positive 1, positive n. So all you have to do is replace x and y, their position. It will become positive. Then by the rule of this one, we can rewrite this as y to the n over x to the n. Either one of them I will accept now. Jamil, the next one. Negative 7x over y to the power 0. Huh? Remember the rule says anything to the power 0 is 1 except 0 to the 0. So anything is negative 7x over y. We don't care what do we have in the base. As long as we don't have 0 on the base, the result is always 1. Kevin, right? Next one. What is 0 to the 0? Undefined. We have no idea. So for 0 power, there are 2 rules. Anything to the 0 or 0 to the 0. 0 to the 0 doesn't exist. Anything to the 0 is 1. Roger, next one. 1 to the negative 100 power. What is 1 to the any power?
1.
So it doesn't matter what do you have. Positive 100, negative 1000, we don't care. 1 to the any power is 1. Vianney? No. All right. The next one is negative 1 because our 99 is odd. And negative 1 with any odd power gives us negative 1 back. Ashley, right? So 80 is even, and negative 1 to the any even power is positive 1. Pressurely, the next one, 0 to the negative 5 power. Undefined, because 0 cannot take a 0 power or negative power. When you have a negative power, it's undefined. If you want to know why, it's actually because negative means it's 1 over 0 to the positive 5 power, which is 1 over 0. But we don't know how to divide by 0, so it's undefined. Vianney, right? 0 to the 7.
Oh, that one.
0 to the 7 means you're multiplying 0 7 times. So if you multiply 0 many, many times, what do you get? Still 0. Shahera, how do you rewrite square root of x in terms of exponents? Square root of x is x to the 1/2 power. So this is called converting radical to exponents. So 1/2 becomes 1/2 power. Nightly, x to the 1/3. Catherine Chan, sorry. So this is nth root. That means it's x to the 1 over n. Okay, who would like to try the last one? From these. Catherine Lynn. Wonderful. M is an exponent, so it has more power. It goes on the numerator. And remember, roots of every problem, root is always on the bottom. So this root will go on the denominator. That's all. These are all the exponent rules we are going to work with in this class. Okay, any question on any of the rules?
Wait. Did you go back to the task from yesterday?
I graded, but I did not bring it because I'm coming from my home. But all the quizzes are on our office room.
So
I'm going to give the quiz back on Tuesday.
what was going to be out of? Was going to be out of 10? 15?
No, the last quiz I graded out of 2. So yeah, out of 2. So if you had everything correct, it's 2 points. If you had at least something correct, it's 1 point. But this one I'm going to grade out of 4. 2 on the left page, 2 on the right page. And guess what? I'm going to give you this again, next week. So if you didn't know how to do this today, make sure you know it by next Tuesday. Okay? Now, how do you apply all these rules? So in our last class, we learned all the rules and we did few examples with exponents. We simplified the exponents and we got something nicer without exponents. And we said, well, one of the easy method is as long as you don't have the square, if you don't have square roots, or if you don't have 2 on the denominator, no, if you have 2 on the denominator, you can rewrite with square root because it looks familiar to us. But when you don't have 2 on the denominator, keep everything and just change your base. Especially. Oh no, I was changing my I know. They're using I? Yeah. So we're going to learn I later, not now. So when you say it's on the bottom, does that mean you have a for this, even I use square root. Anytime you're working square root by using negative number, it turns into I. Only for square root. Not for cube. Not for cube. Cube always exists. We get I usually number when we have square root. But if you have 4 or 6 or 8 of the denominator, we don't get I. We get something different. So we are going to learn about I later. Right now in 10.2. I comes in 10.7. But homework is I'm going to extend the bit. So you can do the homework. If you have no idea what to do, just do the homework based on the lecture. Whatever lecture, whatever materials we go over in class, do the homework and quiz up to that point. The rest, don't worry about that. I always extend the date. Okay, so since we don't have 2 here, we can actually keep our 16 and we work with rewriting 16. And you have 2 choices, either convert the negative power into positive here, or first simplify and then convert negative into positive. Either way, it will work. For now, let me keep the negative power and rewrite 16. How do you want to rewrite 16? Will it help you? What is our goal? A number to the what power?
4.
What power? Because see, denominator is goal. Our goal is to finish this denominator. That means we want something to the power 4. Let's see. And we are so smart. We know if you multiply 2 4 times, it becomes 16. Why did we do that? Because our goal is to cancel these 4s. Bless you. Bless you, bless you, bless you, bless you, bless you. For every sneeze you're going to do, bless you for that. Oh, man. I hope not. Math is one of the cool subjects. So we left with -3 on the top. And now we are going to convert -3 into +3. How? Roger.
Turn into a fraction.
So what goes on the top?
1.
2 to the power +3. And what is 2 cubed? 2 times 2 times 2? 8. So based on the denominator, we rewrite our base so we can cancel the powers. And then whatever remains, we simplify that. For this one, you have 2 choices. Either you can use the square root or apply the same thing what you did here. No problem. I'd actually prefer using the first method. Keep your power and rewrite the base. Now this time, what do you want our power to be? Square, because we have a 2 on the denominator. So what square is for 16?
4.
4. So 16 is 4 square. Two power cancel out. We get 4 with the -3. So what is the next step? We want 3 to be positive. So 1 over 4 cubed. And what is 4 times 4 times 4? 64. This is another number you're going to work with a lot. 4 cubed. 4 cubed, 3 cubed, 2 cubed, 2 to the 4, 3 to the 4. These are the numbers we work with. Any question so far? Guess what? In the final, you'll have one of these to complete. It could be negative power, it could be positive power, it could be anything. Try the next two. Looks hard, but once you start following the steps, it's easy.
Okay.
No problem. You don't have to work alone. Now you can move around your seats, talk to your neighbor. If you want me to rewrite, I can do that for you. We have this with the -3 power and this with -2 power. If you're done, you have more. This with -4/5 power. This with -3/4 power. Do I have more? No. This force. It's so funny, like darling. The first one is very simple. But you're looking for the same number, how many times? Now. So what number is possible to reach out? Inside of two. You want to put 60. All right, what's a little bit also that we think, right? And we'll say, we can see, we have to be. You can see 9, 7, 6, and 7, 8, that can connect is 4. But it's 4 times. And let's see if that's forward.
Yeah, well.
It's like. And the service of. It's similar to it lasts 10 to. That's how I figure out. Go with the.
Yeah. There's teacher power.
Here's one thing. The base is the mass difference otherwise not. It's not even basic. Also, it's not like that. Yeah. This and this demonstration. You must prepare the other strong.
Yeah, already.
But I'm gonna take off the line. This and this demonstration. Now they are saying, we don't prepare the system.
I'm trying to. Something.
You must prepare.
So now.
I'm gonna check everything.
Okay.
Oh. You should
See, that's also want to have this if you buy the one, the whole concept and then it's another 65 and right Okay, what else should I do? It was my PLC. That's fine. It's nine. So I think
I swear. He said it. I know exactly what it's about. But I know it has a little back on the page. He knows that.
And this is one.
I'm not okay.
But besides 0 or 5
That's the one my dad.
since you not to be 6, then will be 5.
Wait, so I have all and that they. That's a good like they haven't. Right. Oh.
You did not listen to instruction. So you did not all the marks. And you can put on and like
That's what's on.
I say that's bad.
I just got it. I
Jewin, number 1, no fun. Number 2, help me with the first one. How you're going to rewrite 8? Good job. 2 to the 3rd. And then what happens? Because they cancel out. We get 2 to the negative 2. 1/2 to the positive 2. Wonderful. Perfect. Quran, you're still late today. Help me with the next one. How are you going to rewrite negative 64? 4 to the power of 3 means 4 times 4 times 4, which is positive 64. Negative 3 or negative 4, which one? Negative 4 to the power 3. And you should put parentheses because you're multiplying negative 4 3 times. Okay, 3 cancel out. What do we get? Negative 4 in the parentheses with the power negative 2. What happened to the negative sign? 1/-4 in the parentheses and then power 2. 1/, what is negative 4 times negative 4? Common mistake. Be careful. Very careful. Be very careful. Ibrahima. C. Sorry, E. Great. So in the exam, if you have no idea, always start with 2. What is 2 to the 5th? What is 3 to the 5th? What is 4 to the 5th? One of them definitely will work. So what happens? Oh, 5 to the 5. Oh, man. 3 to the 5. Thank you. 5 cancel out. 3 to the power negative 4. 1/3 to the positive 4. 1/81. Great. Jean, no phone. Ashley, would you like to try the next one? 4 to the 4. 4 power 4 denominator cancel out. We have 4 to the negative 3. Great. 1/64. Wonderful. Does anyone have any question on this? Remember, in the final, you will have one of these. We don't know which one, at least one from here. So that's how we simplify negative power, fraction power, all these things. And now how do we multiply something with fraction power? So what's the exponent rule says? In multiplication, what do we do with the powers? We add them. So we keep our base x once, and we add 1/3 plus 2/3. Since we have same denominator, so we keep denominator, and we simply combine our numerators. What is 3/3?
1.
So what is the answer? The final answer? Simply x. See, we multiplied two horrible looking fraction, but they turn into a simple x. Kevin, no phone. Okay, Kevin, the next one. So b to the negative 2/9. What happens to that? We cannot live in a negative power. So what is the answer? Really? How do you change negative power into positive power? It turns into a fraction. That's why I said no phone in class. So put in your phone. Negative becomes a fraction. 1/positive 2/9. So you don't flip the power, you flip the whole thing. Rules. And now comes another finalism question. We did similar question before. What do you think the first step is? Roger.
Like I would distribute the exponent into.
So we distribute the numerator exponent, denominator exponent. So we have 4x to the negative 3, 6x to the positive 4. All of them get the individual exponent. Numerator has 3, denominator has -2. Don't do, don't combine, don't simplify. Don't simplify until you convert all the negative power into positive. If you follow this rule, you're not going to make mistake. If you don't, most of the time people make mistake. Roger.
You just like put negative exponent up and whatever is the negative, you just put the other side because that's really.
So first for this, we can simply apply the rules, exponent rules. And 4 has no problem, right? It has positive 3 power. So we can simplify that also. What is 4 to the positive 3 power? 64. And what is x to the negative 3 power with the another 3 power? Negative 9. What is denominator? X to the 4 power with a negative 2 power? X to the negative 8. And this rule, let me change the color actually. This rule is specifically true for this one. When you have a number with a negative power, don't try to do anything. Keep your number with a negative power. So now we see 64 doesn't have any problem. It doesn't even have any power. This has a problem, negative. This has a problem, negative. This has a problem, negative. So everything has a negative power, they have problems. That's why don't do anything with the problem thinking until you solve the negative problem. So if we want 9 from negative to be positive, what do you want to do? Or simply bring it down. If you put it on the denominator, it will become x to the positive 9. If you want the 8 on the denominator to be positive 8, bring it on the numerator. And now 6 has a problem, negative power. So how are you going to solve this negative problem? Bring it up. Every negative will turn into positive if you just switch their position. That's it. So I'm solving my negative issue first, and then I'm going to collect the rest. So 64, no problem, e to the power 64. And then x to the negative 9 has a problem. We bring it down on the denominator, it becomes positive 9. 6 with the negative 2 has a problem, so we bring it up, it becomes positive 2. X to the negative 8 is a problem, so we bring it up, so it becomes positive. Oh, let me put it here. 100, are you sure? So how do you combine powers? Subtract. So which one you're going to subtract? Which one you're going to keep, the numerator or the denominator? We are going to keep the denominator because it's bigger. We're going to subtract the numerator 8. And now the numbers, 64 times, what is 6 square? So freshly, are you adding them or are you multiplying them? See? So 64 times 36. No calculators allowed, so you have to do manually. 6 times 4. So you put 4 on the bottom, 2 on the top as an addition. 6 times 6 plus the 2, 38. And then we leave one place blank. And then do the same thing. 3 times 4, 12. So 2 on the bottom and 1 goes on the top as an addition. 3 times 6 is 18. Plus 1, 19. And then we add. 4, 0 gives us 4. 8, 2 gives us. So we have 1. So 9, 1, 10. 13. So on the top, we have 2, 3, 0, 4. And what do you have on the bottom? So step one, distribute the power. Step two, move, if you have two powers, combine them. Step three, get rid of the negative problem by switching their positions. And then all you have to do is simplify. Question. Was any step unclear? Okay. We have to try them. And then, oh yeah, that's true. Usually they give one of these in the final. So you may see them again in the final. Oh, I did not follow the Today is 9:19. Kaylin here. Daniela here. Alexis here. Sophia here. Evelyn here. Catherine Chen here. Sharon here. Kevin here. Emma here. Koran here. Kira here. Ibrahima here. Diani here. Alex here. Jonathan here. Prashali here. Shinea absent. Bless you. Nicholas absent. Zachariah here. Jean here. Roger here. Catherine Lynn here. Jaylene here. Ariel here. Ashley here. Brenda absent. Juliana absent. Vianney here. Niley here. Brittany absent. Aditya here. Jade here. Jamil here. Santiago here. Jayla absent. Skylar here. Singh here. Okay, done. Are you guys done? Let me ask Emma. Emma, tell me the first step.
Distribute, the power to both bottom and top.
So you have 6x to the negative 3, 2x squared. Numerator gets 2 power. Denominator gets negative 2 power. Then what?
After that, I simplified the 6.
Mhm.
So that's 36. And then x to the negative 2.
X to the negative 6.
That is all.
X to the negative 4. And what did you do with 2 to the negative 2? Great.
Then I switched it around, so I got the top and the top, and then back to the bottom.
So you have 36 times 2 to the positive 2. We have x to the negative 4 times 2 to the positive 4 on the top. X to the 6 on the bottom. Okay, so 36 times 4.
I simplified that.
And what do you have?
That 144, and then I subtracted the exponents, and then I
So we have 6, we keep it, 4 we subtract. So x squared. He did it perfectly. If you don't follow this step, the mistake you're going to make is this one. Either you're going to write this is a 4 or -4. I know for sure. That's what I said. Don't do anything with the negative power until you switch them around to make them positive. Santiago, I'm asking the easy one. The next one. X to the 8 on the top. So 2 cube and x cube. And then what happens? We keep our x to the 8, and what happens to the denominator? We have x to the 3rd with another 3rd. Oh, my bad. Sorry. Okay, so we have x to the 8 over 8, x to the 3. So we keep our x to the, what do we have x to the? X to the 3, because x to the 8 is bigger, and we have 8 on the denominator. This is too easy, it will not be in the final exam. In the final exam, the question is with negative and positive combination. Jamil. Huh? Which one? Which one you're talking about? This one? How do you feel?
1.4 over x squared.
You cannot, because it doesn't have x equals some number on the other side for some reason. You're just simplifying. When you simplify, you cannot put anything extra. Any other question? Okay, we are doing great. And now multiplying radicals and radical expression. When you multiply radicals, there are 2 rules. So one rule. We have to have the same type of radical. Here comes another final exam question. See, in the final exam, they have so many exponents. Okay, so when you multiply, there is only one condition. We have to have same type of radical, same type of root. If you have same type of root, then we are allowed to multiply the inside for every radical. So we have cube root, that means they have the same radical. Since they have the same radical, so we can actually combine all of them together under one radical. We have 25x to the 5, 10x to the 8. But then we observe that, we have a mix of number and variable. So we are going to separate them because we solve them separately. So cube root of 25 times 10 and cube root of x to the 5 times x to the 8. Let's see. Okay. Now, cube root, it means you're looking for same number 3 times here. We don't have to multiply 25 by 10. We can keep it, but we are going to simplify them. If you reduce 25, what 2 number comes in your mind? 5 and 5. If you break 10, what two numbers comes in your mind? 5 and 2. Since we are doing cube root, we want to see same number 3 times. Do you see same number 3 times? Great. So we see 3 5 times, and we have something extra. Since we have this extra thing, so we are going to split our radical into 2 pieces. One is cube root with 5 3 times. And the other one is cube root with this single 2. It has no friends. It's alone. So we keep this alone inside the radical and combine these 3 inside one radical. Well, we do that because cube root and cube power cancel out. That was our goal, to have the radical and power be same. So if the radical and power cancel out, what remains then? F5, which is free. It doesn't have any restriction, it becomes 18. So it's free to do anything it wants. Okay? Unluckily, this 2 is still underage. So it's inside the house. The 5 can float around anywhere, everywhere. It cannot. That's how we simplify numbers. Our goal is to break down the numbers we have in the parentheses, in the radical, into root many times. As soon as you see you have same number root many times, we separate them. Sometimes you may see the same number, you may see 2 numbers root many times. We're going to separate them twice. Okay, now comes the variable. Variable is easier. The rule says in multiplication, we add the powers. Okay. So cube root of x to the 13. And then we divide this 13 by 3. So we get x to the 13 over 3. 3 goes to 13 how many times? 4 times. 3 times 4 is what? That means how many remainders we have? 1. Because we have a remainder, it's just like this one, it's underage. So we trap it inside. R means remainder, and this is 1. So we have 4 free and 1 remainder means not free. Since 1 is not free, so we put this 1 inside our parentheses, inside our radical, because it's not free. It's remainder. Remainder is always extra. But now this 4, it's free. So you put it outside of the radical. So this x has 4 power free, but this 1 power not. Okay. So what we do is, this is free and this is free, say, hey, become friends. So they become friends. And since these are not free, we put them together in the house and say, hey, play around now. So inside the house, 2 and x, they play around. And outside the house, 5 and x to the 4, they dance around. And this is our final answer. So there are 2 methods, one for numbers, one for variables. Numbers, we look for same number, root many times. For variable, we divide the power by the radical, the root. The whole number goes outside as a power on the variable. The remainder goes inside as a power on the variable. Was any step unclear? Okay, practice. I believe I have 4, no, 2. Follow the steps. And for some reason, they actually like cube root. I don't know why. So you have cube root of everything. But the rule applies for any type of root, square root, fourth root, fifth root, sixth root, it doesn't matter. The rules are same. You can talk to your neighbor.
Kind of hard. Separated them, you didn't talk.
Quiz meant to be for a single person alone. So sleep with you all as single. You don't have any friends. But after quiz, you can be friends. So yeah. When it gets strong, meaning lecture was. That's so we have 3 times. 5 and 9. No, but I got it right. Come on, you have to help us. Something else. Why are you shy? Because she's expecting. No. I. How are you doing? She always be love. I just. Do you know what he's doing? No, we always do.
Yeah.
None of the birthday.
Me.
I did. and one alone. Why? Because the power that's very good. And you can see, can you see the same number? You can see, right, you have 3 times and the 1, 2, 3. Yeah. It's because we're not working. Yeah. It's because we're. And now for variable, it is so. It's a no, no. Yeah. And how many percent to the 14? It's 32. 8 times 3 times. No, oh, you are. No, because you try 9, 5 times. In the number, do you have anything arranged? Yes, we did. We did. Yes, because of yeah, whenever you go out, no, I see. Right. Right. Because why is it good to this will always be like, one thing. Go ahead. So then, so we want to the first thing that but then again, I don't work with it. No, it should be. Yeah, so how is it possible? Break it down. You have to keep bringing your numbers down until into the same number. No, now.
Yeah, that's why I'm
So last year, you take 6 cents. I'm telling you 6. So what you want to try? You're dividing, so you may how was one? That number.
Yeah. I'm saying, you break that.
Oh, okay.
No, I know, but you have to break that.
I'm gonna try it. Exactly. And then what's this?
Why? Why did you? I mean, why do you have to in my every time I don't know why. That is to the point that types.
What is it, sir?
Maybe it's not matter because that's because it's not 9. Yeah. You got it? That's what I didn't read.
I really don't.
So point of the last branch. And we want the response to the whole row. And it's. So now you almost correct. Let me stick it here. It doesn't go 4 times. It goes
Guess I took.
For me, that's yeah. What about you? Okay. I try. Yeah.
It was a type that part. And yeah. And like, how does it? Very well. You do. And then. I was watching it. And then. Yes. Here's boss. Exactly. No. You got a lot. And I said, no, I think.
I don't do that.
Yeah.
I'm not.
So it's gonna be two.
Yeah. Oh.
Okay, what do you have next? Multiplication? Okay, let's do them together. So we put cube root of 9 times 9 and cube root of x to the 5 times x to the 9. Jean, what did you do with the 9s? What did you do? And then you split it, right?
27 and
And then what did you do?
did I simplify 27 to then it will be 3.
So you have 3 times and a single 3. So this gives you 27, right? 3 times 3 is 9, 9 times 3 is 27. So we split them into 3 pieces, 3 cubed and single 3. What, Aditya, what happened? He's doing a different method. It's okay, it's fine. But I'm showing you this one because I found student understand this better than you, the method you are using. Actually, I always use your method, always in my life. Until recently, I learned this and found that, well, student understand this better. So I thought, okay, let me stick with that. So cube root, cube power cancel out. We get a single free 3, and we have a lonely 3. Now, what did you do with the variable? X to the, and then what did you do? You divided, right? So we have x to the 4, because 4 is a whole number. Every remainder is not free, so it goes back inside the radical. So these are free, 3x to the 4. These two are trapped, underage, lonely. So we let them be friends. And these are final answer. Any question on this one? Aditya. What do you mean?
The three next to the left of the next.
Yeah.
The left, other one to the left. Yeah, no, the other one. Yeah, that one. What if we left that one out? Yeah.
So we are writing 3x squared and 3x to the 4 and 3x squared. It's wrong. Because this 3x squared is not real like that. It's inside the cube root. And this is a very small amount, but this is a big amount. Okay, let me do the next one on the right page. Cube root of 3x to the 7, cube root of 18x to the 9. Since we have numbers and variables, so we separate them. X to the 7, x to the 9. And now this 3 becomes 1 and 3. Now 18 becomes what? 9 and 2. But our goal is to see the same thing 3 times. Do we see the same thing 3 times? 2 we cannot break down, 3 we cannot break down, 1 we cannot break down. That means the only thing we can break down more is 9. What 2 numbers gives us 9? 3. And now we cannot break them down again. Now, all those circle ones means those are the final result. So in the final result, in the final branches, do you see the same number 3 times? What number you see same thing? So we put them together. Our goal is to see the same thing 3 times. We've seen it 3 times. So inside one cube root, we have 3 times. Inside another cube root, we have all the extra things. So this was extra, this was extra. We multiply them. What do we get? 2. Sometimes you're not gonna get 1, but you're gonna get other numbers as extra. So whatever number you get extra, you multiply them. So cube root, keep power cancel out. We get a free 3, but we have a lonely 2. What about the variable? What do we get for the variable? 16. And then 3 goes to 16 how many times? 5 times. Remainder 1. Remainder is the lonely one. It goes back inside the variable as a power. The whole number 1 goes outside as a part of the variable. So what do we have free? And what do we have lonely? 2x to the 1 power. If you don't want, you don't have to write 1. Simply down. So they like to give this type of question in the final. Any question? So today we learned many final exam questions. This is one. These are another type. And these are another type. So 3 questions we already have in the final exam from today's lesson. So in our next quiz, I'm going to give you all the exponent rules again, and one from these 3. One of them could be this type, or could be this type, or could be the multiplication type. Okay, so one from these 3 types and all the multiplication rules. So not multiplication, power rules, exponent rules. And I can let you go early today. We learned a lot today. Thank you.
I guess I shall.